we are waiting for our first speaker to join us here in our virtual room. So this will be Javokhir. We'll ask him to turn on his camera. Yes, he is with us. So please bring him to us in our virtual studio. Hello, Javokhir. How are you?
Hey guys. Yeah, I'm good. Thank you. How about you?
Good. Thank you very much. So we will start day number 3 with your talk. Can you maybe tell us a couple words? What would it be about?
Well, it would be about a microservice pattern, so mainly about a sidecar pattern. And we will talk about the sidecar pattern by seeing an example as using the Envoy Proxy pattern. And we are going to have some coding examples as well. So it's not going to be just like a live coding, I would say, but it would be like we would go through the code example and see, make some requests to our systems and see how it works. But we will start by giving some technical background about what the sidecar is, why we need it, and what is the Envoy of it, and what kind of different implementations of sidecar do we have. And then we will move to the workshop part and then to the QA part. Yeah, thank you.
Okay, that's wonderful. So we would ask you to share your screen, and meanwhile you're sharing, I want to remind our audience that we have 2 chats where we're collecting your questions, your reactions, anything you want to share with us, and I do really encourage you to share it with us. It's an online conference. We cannot see you, unfortunately, but we still want to hear from you. We want to feel you near us. So please use this opportunity. We have chat on YouTube right here near the video where you can see us. And also we have chat on VR community platform. Me and Alexander will monitor both of these chats and try to get all your comments, all your questions, and ask them in the end of the session. So, say no more. Javokhir, good luck. Let's start, Javon, day number 3. Let's go.
Okay.
Let's get started and go ahead.
Thank you, guys. Yeah, thank you. I'm super excited to join here. Yeah. So I guess you can see my screen already.
Yes, we can see.
Yeah, I guess yes, because I can see it. So let me just introduce myself. So my name's Javokhir. So as my name suggests, I'm a Java developer. I'm from Uzbekistan, from Tashkent, and I work at EPAM as a software engineer for 1 year and 8 months. So yeah, in fact, this is my first time being on that kind of conference on that level. So I'm super excited for being here, and thanks for having me, guys. Okay, let's start. So today we're going to talk about the microservice patterns. So mainly about the sidecars, which I described already, with using examples of Envoy Proxy. So here is our agenda for our topics. So we're gonna briefly talk about what is a sidecar proxy pattern is, and the key characteristics of that sidecar. And we will talk about some popular implementations of sidecar proxy. And we will go to the practical case where we'll see simple service mesh architecture, like a service-to-service communication between the 2 services, which we have developed using 2 different languages. So it is like a microservice architecture. So they will communicate with each other using a sidecars. And then, as a summary, I'm going to talk about pros and cons of using the sidecars. Then we will move to the QA session. But yeah, you can actually put your QA questions in our chat, yeah, as Roman already mentioned about that. Okay, so yeah, here is a kind of popular meme about that, yeah. So let me just, I guess most of you already know about microservice architectures. And microservice is like a service which is focused primarily on the business logic. So it's not focused on, I mean, the application itself is already decomposed by the service, by the business logic it will actually achieve. So in our sidecar, we actually use the sidecar proxy patterns. In fact, the sidecar, so the translation of the sidecar is like, you know, you know, the motorcycle. So there is a cabin near to the motorcycle. So we call it the sidecar. So it's actually the helper to our main application. So in our case, application is just a service, so microservice. So the sidecar is a helper function for it. So we can see that, like, for example, incoming requests wanted to go to the service, but but firstly, that incoming request, we also call it ingress request as well. So I'm gonna say ingress, but you should understand it as an incoming request. So so that ingress request will be intercepted by the sidecar, and that helper functionality, which is not the core functionality of a service, will be executed. So, which is, you might ask, what are the helper functionalities are? So here we can see that the sidecar, in fact, the helper service can do several tasks, such as the platform abstraction, the proxying, the services, which is pretty much the obvious, because without the proxying, how the request would go to the service itself, and logging the configuration, and also besides of it, we do have a authorization, authentication. We can do the authentication as well, MTLS, mutual TLS termination. So all of that we can do on the sidecar level, so that it would give us, so that we can focus only on the business logic on our core application. So we don't need to implement a authorization for our every resource microservice. So it's just it just gives us an opportunity to remove some kind of cumbersome code from our main service. So our primary job would be just to develop a main application with its core business logic, and that's it. And all of that logic will be takes place inside of a sidecar, like a authorization and like logging and anything like that, which is not a kind of related to the main application's core functionality. So we can see that here are some of the popular sidecar implementations. So Envoy, Proxy Sidecar, Linkerd, and Istio. So in our example, we're gonna use a Envoy. So Envoy, it is a native written in Lua programming language. So it's actually the lightweight one, because in fact the sidecar should be a lightweight. And Linkerd is also another implementation of a sidecar. It is a cloud native, and also it's a lightweight. And Istio is a pretty much a bit advanced version of Envoy, which gives us the whole control over our sidecar management, because using Istio we'll be able to create a control plane and a data planes. So I guess on the next slide, let me show. Here is, for example, we can see that using the Istio, we would be able to create a control plane here, and so that we can inject the necessary configurations into our sidecar. So we call this part as a data planes. So in fact, we deploy the sidecars just besides to our services inside of a one pod, but in a separate containers. So you might imagine it as inside of the same Kubernetes cluster. So we have a one pod here, and we have two different containers of sidecar and a business logic service. And the control plane gives us an opportunity to configure the sidecar, like by passing some environmental variables, or we can do, for example, can inject the permission sets, for doing the authorization and something like that, So, but we will mainly focus about only the data plane part, because it would be a huge topic, yeah, if we will talk about the Istio side as well. So we're gonna we'll go away further from the backend development into the more darker side, yeah, to the infrastructural side of a DevOps world. So yeah, so this is why we just diminishing the scope of it and focusing only the data plane part of it, with just like having a communication between the services, yeah, using a using a containers of the services and the sidecars. So you can see here the key characteristics of a sidecar. So they can be developed and deployed just beside the service, so it's not a dependent on the service, so which is makes it pretty much flexible. So there is no any dependency of it. So in fact, the sidecars is also a language agnostic. So that means we can develop the service in any language that we want. For example, our one service can be can be developed using a Java programming language, and other one using a Python, and another with a Node.js. So the sidecar wouldn't care about that. And yeah, because this is actually the truth for the microservice architecture. So in fact, you might imagine that sidecar itself, yeah, how it interacts with a service, it is like a microservice inside of a microservice itself, yeah. So like when you imagine the microservice, we have an API gateway, services, yeah, discovery service, and etc. But when we take a closer look to the service itself, so it should have a sidecar besides of each service. So the sidecar acts as an API gateway as well. So somehow like that. And we will talk about the difference between the API gateway and the sidecar proxy as well. So, and also another key characteristics of it, that it has a independent life cycle. So that means we can actually deploy it and destroy the sidecar pretty much easily. We can scale up and down. And yeah, it would, basically, most of our sidecar implementations are resource efficient. So they're not consuming pretty much big amount of data, big amount of memory. So this is why they are pretty much efficient enough. And we are having in terms of the security part, we are achieving the isolation of our service, yeah, because we are not allowing like other service to go inside to that service, even they are inside of the same infrastructure. If that service has some predefined authorization, yeah, some permission to go to call other service, so then the sidecar will gives a green light to that request to go to its service. So yeah, here is our difference between the API gateway and the sidecar proxy. So here we can see that the points about where we can see some differences of using a proxy, sidecar, and API gateway. Of course, they can be used together, yeah, because we can actually achieve a better architectural design by doing so. But mainly, like API gateways, like external API for incoming requests, like from outside of the world, yeah. So in our API gateway, we actually take care about the authentication, we might have some another service which would responsible for obtaining the tokens, yeah, for giving the tokens. So, but for the sidecars, it's like a inter-service communication. So it's mostly like a service-to-service communication. So this is mostly about checking the permissions of a particular service, whether or not it has some permission to call other service. Yeah. So it is mostly like an authorization part on the sidecar level. And API gateway is a centralized in scope of the deployment, yeah, because we have only one API gateway for our whole application, for our whole microservice architecture. What about the sidecar? Sidecar is deployed alongside each microservice. In terms of the responsibility, so it is the sidecar mostly like about a low-level communication because it happens like behind the closed doors, yeah. But API gateway is like high-level concerns, and as we mentioned already, the granularity of it is like a macroscopic view of architecture is like an API gateway, and the smaller scope, the micro level of it can be a sidecar. And in terms of the flexibility, so we can diversify client needs using a API gateway. Yeah, so it's mainly for that, and we can give a fine-grained control for the sidecar. Yeah, by specifying what kind of ingress requests and what kind of egress. So egress is like a outgoing request from the sidecar, from the service through the sidecar. We call it egress. If it's going into the sidecar, we call it ingress. So we can actually define some rules, policies to define, to control, to get some control over what kind of requests can flow over our sidecar. So this is why we have a fine-grained control over the sidecar. As a result, we're having that level of control over our services. So in our example, we will here mostly is like, this is in fact the simple service mesh architecture, how it looks like, using the Istio. So it's actually, Istio is used alongside with the Envoy, to control the behavior of Envoy to pass some like configurations, and etc. But in our example, it's pretty much the simple one. So we have two services here, like a product service and inventory service, and our incoming requests will hit to our sidecar, but in a real world, of course, we should have a API gateway here. So the incoming request should hit the API gateway, and then API gateway should proxy that request into the sidecar, and then sidecar proxying that ingress request into the product service. So in fact, we have enabled the integration with the key cloak, which is a famous implementation of the authorization service. But only for the authentication, not authorizations, because like for the authorization, it would be like another topic for discussion. So what we're having here, we need to obtain a token and we need to make a request with that token to the endpoint of our product service. We should hit the product sidecar, and then it should verify whether the token is valid. So if it's valid, it would allow us to go inside and we will do some business logic. And internally, this our product service, it calls actually the inventory service. So the product service actually developed using the Python Flask. So this is just a proxy service, and the inventory service is developed by using a Java Spring. We have a in-memory database here with some records, with some predefined records, which would return the value corresponding to that request. So so the communication here would happen through the sidecar. So we're going to see that in our example just in a moment. And let's move to the coding part here. So I'm gonna show you here just take code examples here of our application. For example, we have a product service, which is developed by the Python Flask. For example, we are making a request to our sidecar of our inventory service. If it's not okay, we're gonna throw an exception, saying with some message here. And if it's okay, we just responding with a 200 status code. And let's see the inventory service here. So inventory service here has such an API, as you can see, with only one endpoint, which is a get endpoint. And we are retrieving the record by ID. So we have here this pretty much the basic data, yeah, with these values. So it has these properties here, and this is one just for the testing. We don't need it. In fact, I can actually delete that one. Okay, so this is pretty much of our services. Let's see our sidecars. And the sidecar for customizing our sidecar, yeah, for just writing some code, yes, for just like enabling some features, we need to specify. We need to create such called a YAML file, or we can do using a JSON files as well. So this is how it looks like. For example, let me show the Docker Compose firstly. So yeah, we are creating a Docker containers. Firstly, we need to create images of it. Yeah. So, and here is the containers of our sidecars. So this is how we need to specify that the configuration of our sidecar should have an impact, and we should see that sidecar with our configuration. So let's see the Envoy product here. So we have in fact the static resource and also dynamic resource. Yeah, and dynamic resource, so it's mostly like with a control plane. So we're not gonna focus on that. In our static resources, in fact, it's not a requirement to specify. As you can see, let me make it a bit bigger in terms of the size. And yeah, we need to specify the listeners. So listeners is would be a URL address of our sidecar. Yeah, we need to specify the port. So like exposing the port for the incoming traffic. And then we are specifying the filter chains. So then we are saying that we want to use a connection manager filter. So this is responsible for the HTTP connection. So it's saying that ingress HTTP. So, and then based on these routes, so we're having a like enabled for all domains, yeah, but we can actually specify our like domain as we want, yeah, because in order to avoid a cross origin request surgery, if I'm not mistaken, to avoid that error, so we just specifying that sign here, yeah. So, and we are specifying here some prefixes, like for example, if we have seeing such prefix, we should define the incoming request to this cluster, otherwise to that cluster. So this is how we specify our filters. And we having another HTTP filters as well. Inside of the HTTP filters, we can write our own customized version of filters as well. Yeah. So as I already mentioned, that the native language that is used for writing the Envoy is Lua and C++ mainly. And that's why we need, it's better to use a Lua programming language, yeah. So in fact, here we are specifying an inline code here like that, yeah. And we need to like import that configuration and call that envoy on request function, yeah, with a request handle param here, and call the main function inside of our inside of this package. So you can see that here we have a logging.lua file, which is responsible for logging purposes. So we actually have created here just simple filter using a Lua, which is responsible for like logging some requests. Of course, we can do that by using some predefined filters, but yeah, but for the sake of the example, how we can write our own custom filters. So I created this file here. So this is how we specify it inside of the function on envoy request here. And we also can write a function envoy on response, yeah, like, but it would be like a kind of post request logic, yeah. So, but we don't need that one right now because we are focusing right now is just like to see that what kind of requests are coming into our sidecar. And here, another example of our filter that JWT auth n, so which gives us an opportunity to authenticate our request, yeah. So we are specifying the issuer of the token, yeah, and parsing the token here, and yeah, like forwarding the token and specifying the URI to the cluster, like specifying the timeout time for how many times it should try to establish the connection. And we're also caching the token value here inside of a sidecar. So we can use that. We can actually use that sidecar for the caching purposes as well. So, but it gives us for the authentication, yeah, like ability for the authentication. But if I'm not mistaken, we can use a authorization filter of a sidecar, but it would take a bit longer, yeah, because I actually tried to do that and I thought I came with a conclusion that it would take a long time. So yeah, and I decided to stick with a more simpler approach with using a just authentication on the sidecar level. So and also for the authentication, we need to specify the rules that every prefix, yeah, so that every route should be checked for having the token, yeah, in our request. So no request should pass without a token here. So at the end, we need to specify that with a router filter here. And yeah, I already mentioned about the clusters. Yeah, as we can see that we have a product service cluster, the sidecar inventory cluster, and the key clock cluster. So our sidecar is like a one service, yeah, and it should know that where should it send the request. So we should specify the clusters, yeah. Inside of a cluster, we can actually write one or more than a one service, yeah. We can specify it. We can actually group some more than a one service into a one cluster and specify some logic there, yeah, in what kind of way the request will be go to the particular service. So in our example, we're just having a one service behind our sidecar, because yeah, it's better to have only a one sidecar, one service behind every sidecar, yeah, because it is like a helper for our service. So we're having a product service here, and we are specifying that address of a product service, which is the address of our Docker container with this port. And yeah, we're specifying the endpoints, giving the name. We can actually, of course, give some random name, but it's better to stick with some meaningful names. We're specifying the connection timeout and load balancing policy. Usually is a round robin. And we can write, actually, you can see that I write the name of our types and policies. Yeah, so it doesn't matter. It can be either in an uppercase or lowercase, so it doesn't matter for our Envoy configuration. So it would understand that anyway. So here we can see that it's pretty much the same for the key clock here. The same type of load balancing policy. We can actually configure some load balancing policies for our sidecar, customize it. And in fact, it actually acts as a reverse proxy as well. So yeah, so we might have a different instances, so several instances of the same service. So depending on the requests, we can actually specify, we can actually send those requests into the different instances of the same service. So yeah, we can do that because Envoy gives us such opportunity to do so, because we can configure that load balancing policies here. And we, of course, need to specify the sidecar as a cluster as well, because we are making a sidecar to sidecar communication. So incoming requests. So in fact, like as we saw in our example, like in our schema, let me show it one more time. Yeah, so like incoming is like a ingress coming into our sidecar product, yeah, and going out from the product and coming inside of, in fact, when the request has went through the sidecar, it's called already an egress request, yeah. So this is again like we had some logic here, some executions here, and request is going inside of our sidecar one more time. So this is again a ingress for our sidecar. Then it is like going through it and just proxying towards that cluster, which we have specified here as a sidecar inventory. And this is why we have specified here just a one stat prefix, yeah, in our HTTP connection manager as an ingress HTTP. So there was no need for us to create an egress HTTP as well, because if we wanted to do that, in fact, we have to create two separate listeners, yeah. But in our examples, it's not needed. Okay, and also it has a admin endpoint, like we can specify the access logs, yeah, and to see some metrics, to see some data about our sidecar, yeah, about its upstream. So in fact, we also may call it like ingress request, yeah, like a downstream request when the request going to the to our service, because it is like place it behind the sidecar. So this is why we call it like a downstream, and the upstream when the requests are going from the service and passing through the sidecar, it is like a upstream request. Yeah, so it's like a going out from our sidecar. So yeah, this is another definition here. So we can see that we have a such a one downstream cluster, and in fact this one is a upstream cluster because we are going from our Envoy product sidecar to the sidecar inventory. And key clock is as well, we can consider it as an upstream because we are making a request from our sidecar towards the key clock. Okay, and let me show you the Envoy inventory as well. So it's pretty much the same configuration here, but we have a specified the different port here, but just for the visibility purposes, we can have the same ports here. Like we can in fact specify the URL addresses of our sidecar as a discovery information in our API gateway. So yeah, it should be used in cooperation. So in order to create a better architecture. So in fact, this is pretty much the simpler because we are just like forwarding the proxying the request to our inventory service. So again, we are using our custom filter for logging the request. So log request function. So you can see that it is a log request function. And we have the clusters in inventory service and the key clock, but in fact we are not using a key clock here because you might see that we are not forwarding the token because we are not forwarding the token to our upstream request. Yeah, so this is why we haven't used the key clock cluster here. We can actually remove that, or we can add that one as well. So I had in mind that to add the authorization part of it, but then I decided to stick with that authentication part. So like this, in order to have a much clearer view, let's remove it. Okay, in fact, I just forgot to mention about the Docker file that we have here. So the Docker file is pretty much the simple one. We just need to specify the base image of Envoy Proxy that we wanted to use and copy our custom files into our ATC Envoy file into that directory, that file logging.lua file into that directory, and we are calling that like importing that and calling that function like that. And then we're just like executing the command to start our sidecar. So this is pretty much it from the explanation part. And let's see how the requests are being traced, how requests are being flown between the services. So let's see that. So here we have let me check like Docker here. In fact, we have up and running services. We have a key clock inventory service, which is indeed a Spring application. So it is initialized already. And we have our records have been imported as well. And key clock. And we have a product service here. and our Envoy Proxy sidecars. So, in fact, Envoy is doing the job of the Nginx service, Nginx server as well, yeah, because it is like a proxy service. Because Nginx as well is been like a Lua programming language is used to develop a to develop the Nginx service, but Nginx is like a if I'm not mistaken, yeah, but it doesn't gives us such more flexibility as Envoy gives us, yeah, in terms of the authentication, authorization. But maybe we can do some custom like authentication, authorization, yeah. But mostly it's like use it for the load balancing and like for logging some request, yeah, because yeah, and also what gives us like Envoy in terms of the logging, we can actually measure the UCT, yeah, upstream connection time, UHT, upstream header time, and such headers related to the timing of how efficient is our request can be shown with those request headers. So we can see them in our product in our Envoy proxy sidecars as well. But yeah, I haven't enabled that debug mode because yeah, it would be too much like info about that. So yeah. And also you might ask why we need how it's happening like service to service authorization. So in fact, we can create in fact, when we have an authorization service, so in fact, every service that we have should have its own client ID inside of a key cloak, yeah. So it should be like based on the multi-tenancy, yeah. So it should be like a multi-tenancy. It's like having a multiple realms, yeah. So to have a isolation between the different vendors depending on whom we are developing the product, yeah, because the same application, yeah, the same architecture, but with different database informations, yeah, with different database records inside of our DB. So in order not to have to fix them, yeah, we just need to have a multi-tenant environment, yeah. So Keycloaks gives us such an ability, yeah, having the multiple wheels. So inside of a wheel, we can create a couple of clients. So in fact, for our each service, you need to have a separate client ID, yeah, with a client secret. So we can enable the client-to-client authorization, which is like a client credentials flow, yeah. So, but in our example, I'm just like receiving a token as a admin user, but it would be better to have using the client to client credentials flow, yeah. So it would be like that, like product service would get that get its token, yeah. But in fact, yeah, the request, already user should have that token, and it just the sidecar just checks that one, yeah. And or just or it can make a request, yeah, because incoming token can be a huge become a huge, yeah, because it shouldn't kept all the permission inside of it, yeah. So user shouldn't know that because it would take it would lead to the higher latency as well. So that's why we need to have a lower like amount of information in our like a token, which is coming from outside world, but inside internally. So we can enable that inside of a sidecar. So to call the key cloak and use a client credentials flow, obtain a token, and when when one service, like after finishing some job, after finishing some operation, wants to call the other service, it should like pass through the sidecar by getting that token, and that sidecar should check that whether or not that service has some predefined permission to make those calls to this service. So let's see an example here. So I'm having a key cloak here, like let's obtain a URL, the token, and let's make a request. So yeah, we are getting a, let's try to get another information. Yeah, so we are getting like, we don't have a record for the 3. So yeah, it's showing us an error. So yeah, it can be done better, but it is what it is right now. So let's see the logs here. For example, let me open up the Sidecar product container. So we can see that our custom log has been called up. Yeah, so having like seeing that get and pass, like method get and the pass of it like a products, and we don't not passing any headers here. So in fact, token should not be visible, yeah, as we all know, on the logs as well. And yeah, let's try to check a inventory. Yep, indeed. So we can see that this product, we are calling the product service, yeah. So we can see the like logs here of the product, yeah. So it shows the 500 error, like if it's not found, yeah. Of course, I should have done like 404, but yeah, right now it doesn't matter. So yeah, we can see that we are making a request to the product service. But firstly, it is like going through the sidecar product. Yeah. Let me see the URL, which is a localhost 8082, which we can see. Which we can see here, like, yep, indeed, we do have such ports for our sidecar product. Like, let me exit the full screen, yeah, in order to avoid to go back and forth. In fact, I can right now close the window. And yeah, so we are like hitting the product sidecar, and it calls in my time, I guess we can see that as well. It calls the product service, and the product service calls the sidecar of inventory. Yeah, so we can see that the log clearly shows that such endpoint has been called up. As a result, our inventory service also shows an exception that inventory not found. Yeah, so if no record is being found. So there is no record, like when we like make some successful requests, it's not printing anything like that. So yeah, in fact, our sidecar can do the logging for our application. Yes. So, And yes, for example, let me like try to use a invalid token and see what might happen. Or might be the token is already expired. Yeah, so JVT is expired, we can see. And let's see that did our like request, no, it hasn't reached the product service. So, but it actually shows that because, yeah, because order of it like matters, yeah, because I placed the logging functionality on top of the JWT, yeah, on top of the authentication. So it is, so here order matters. So from up to down. So the first filter will be invoked in a first order. So, and let me like, for example, try to like remove one element and let's try to yeah, we can see that the header is invalid. Maybe let's try to see the key cloak. Yeah. So it's not showing some some information that we need here. Okay, and let's move back to our presentation. Oops. So let me find that one. Yep. Okay. So we can see that that was our example of our simple service mesh architecture, like a sidecar to sidecar communication, service to service communication using sidecars. So what kind of benefits and yeah, trade-offs it can gives us? Yeah. So on the first hand, it gives us like a simplified approach for developing the microservice. Yeah, because we don't need to like add some logic for the authorization, logging, yeah, and etc. inside of our microservice. Yeah, we're having a better observability, monitoring, and also having a better scalability and resilience because we can scale up and down those instances, and yeah, we can choose the load balancing strategies. Yeah, but the drawbacks of it, yeah, using the sidecars, it also creates a additional, yeah, resource overhead because anyway, regardless that they are lightweight, but of course they are like consuming some memory space, yeah. And also, in addition to this, we're having a potential, yeah, danger of having a single point of failure. So when like sidecar, what might happen when our sidecar becomes a unreachable? Yeah, so then like so we can do nothing. Yeah, like we can actually, in fact, or we can, but we can actually create a couple of more sidecars. Yeah, we can define that one as well. But anyway, it would be like not a nice architecture. Yeah, because and we can create a control plane yet to avoid having a single point of failure. Yeah, because but anyway, like using the API gateway, it has a single point of failure possibility. Yeah, such a danger of possibility as well, and of course additional latency because again we are adding another like a lightweight service between our services. In fact, so it is need to go through our sidecar, not go directly to our service. So in addition to this, it's actually adds some couple of milliseconds on top of it. So this is why it has some like, even it's a small, but adds some a little bit of latency. And of course, yeah, it might sounds a bit silly, yeah, somehow we're having a simplified configuration of microservice, but overall the architecture becomes complex. Yeah, so if it's like we have a couple of more sidecars, so it would be like we need to implement that the control plane here to control the sidecars. So we need to like customize them, and yeah, that would be difficult to do so. So yeah, and also I forgot to mention that about dynamic service discovery. Yeah, so inside of a load balancing part, we can do see that it's actually like depicts that by the name of it, yeah, by the name of the service, just finds out the service by its name. Yeah, so we're having a like discovery service. Yeah, we can use it as a discovery service as well. Yeah. Load balancing, as we saw, yeah, TLS termination, yeah, when we're having a certificate, yeah, over a HTTPS network. So yeah, it gives us such an opportunity to do so. We can add a like additional filter for that purpose, yeah, to do that TLS termination. And it actually supports both gRPC and HTTP2 proxies, but also it has a like a router for the Kafka, and yeah, but Kafka, if I'm not mistaken, for the RabbitMQ, but I'm not sure about the RabbitMQ, but for the Kafka it does have a such a router to use it, yeah, but it is mostly like having a REST calls between the services. So as we saw that it has a circuit breaker pattern. Yeah, it checks that it might check like whether or not the service is healthy, yeah, and send the request to the healthy instance of it. Yeah, so we can have a percentage traffic split. Yeah, staged rollout. So it is like a choosing like which percentage of incoming requests would go to the particular instance of it. Yeah, so it is like a canary testing, something like that. We can do that. And fault injection, yeah, we can do some like that as well. And of course, we're having a rich metrics. And of course, I just forgot to show you guys like, oops, we're having a recursion here. Envoy admin, yeah. Here's how it looks like. The Envoy admin panel, yeah, so it is like, doesn't look that beautiful, but it is what it is. So it is for the inventory service, yeah, as you can see. So it's a sidecar for the inventory service. Have some metrics. We can see the heap dump, yeah, like listeners, some information about it. And the same like for our second sidecar. Yeah, you can see the information about that. So it is for the inventory. Another one, I guess, was for the proxy, yeah, product. Because here we have one. Yeah, here we have a inventory service, key clock cluster, and what else? Yeah, inventory service. And yes, this is how it looks like. We can see some information about them. We can enable the Prometheus as well. Okay, and yep, I guess let's move back to our slide. I guess we can move Q&A session.
First of all, thank you very much for such a great talk. That was really a pleasure to having you, and thank you for starting day number 3 of Java conference. We do have a couple minutes for talk, so I pass the voice to Alexander to ask them.
Yeah, thank you, Roman. Thank you very much for Javokhir. I know for sure how hard it is to be the first on such a famous conference. So kudos to you. And we have many questions in the chat. Let me ask just a few of them. We don't have enough time. We have a question, and it's mostly about why should we consider using Envoy Proxy? Because first of all, it introduces additional complexity. It's necessary to write code in Lua, but why should we consider using it instead of, for example, something like a Spring Cloud Gateway?
Okay, this is a nice question, actually. Yeah, in fact, the Spring Cloud Gateway is an implementation of API Gateway. Yeah, but Envoy, it is for the sidecar. It is like a micro level of our. Or it is not the same as the API gateway, yeah. So it is just like stays alongside of our service. So we can use the different implementations as we saw here. So it shouldn't be the Envoy, but in order to avoid writing some cumbersome code by ourselves, yeah. So we it's sometimes it depends on the business needs, yeah. So you can use the Envoy if you have some like requirements, yeah, like for having a lightweight application. So yeah, like a faster, like a deployment, yeah, faster, like a creation of the sidecars, so and etc. But we can actually create our application on our own, like using for example, Quarkus, yeah, Quarkus framework. We can actually write our sidecar from scratch because it is also a reactive, lightweight, yeah, like a subatomic, as we heard that like framework, which creates a lightweight application, but it would be will take a bit longer development time than like implementing it using the Envoy proxy. Yeah, but Envoy is much simpler way of having the sidecars.
Good. Thank you very much, Javokhir, for answering the question. I have a follow-up question really on the same topic. So as you mentioned, we have modern frameworks like Java, like Spring, Quarkus, Micronaut, anything else, and majority of them have, let's say, modules which allow us to put some cross-cutting functionality on top of our services, like a Spring Boot starters, for example. You add a dependency and you get a cool functionality out of the box. So the question is, when should I consider start using the Envoy or any other, for example, sidecar, instead of building in or plugging in these capabilities into my application? From which point I should start using it?
So mostly like when it comes to authorization part, yeah. So when there is a concerns, like for example, you're having a like third-party libraries, yeah, like so, and you need to achieve that the project that you're working on. So like it is like the private project, yeah. So it's not accessible. So it is like a microservice. So because of the security concerns, yeah. So every module like should have its own authorization, yeah. So when the module to module communication happens, so it shouldn't be like just one module calls another module, yeah, and the request should go without any authorization. So in that case, so it comes handy to use sidecars because of the authorization purposes, because like we define the permission like for our service, for our each service in our microservice architecture, yeah. We can actually define the permission for our each endpoint, yeah. For example, it can be like in our example like inventory ID, yeah. So it can be like get inventory ID, yeah, or like a post inventory. So it can be just a name of the permission, yeah. And we can group that into the one policy, yeah. For example, create policy, like a get policy, and read policy, write policy, and something like that, yeah, as like in the AWS. And inside of that sidecar, we can cache those policies, those permissions, and when the other service calls, when the call happens between the services, so the requests are being intercepted by the sidecar, and it checks that whether that request, that calling service has actually the predefined permissions to call that service. Yeah. So because of that service-to-service authorization, so this is why we need to enable like client credentials flow on the key clock side. Yeah, and like persisting the token, like in not a token itself, like, but we can actually like cache it for some minute. Yeah, like in order to avoid like checking every time and going back and forth like between key clock and the sidecar. So for that purpose, yeah, mainly for the authorization purpose, not authentication, but for the authorization purposes, we are using the sidecars. And yeah, and replace like, yeah, and like some architectures like using a Nginx besides the modules. Yeah, so and also to avoid using the Nginx. Yeah, because sidecars tend to be a much lighter than the Nginx services itself. So this is why.
Yep, good. Thank you very much for answering the question. Now it's crystal clear when we should consider using the Envoy proxy. And again, thank you very much for such a fantastic talk and kick off the day. Good, thank you.
Thank you very much. See you on the conference. Bye-bye.
Bye-bye, guys. Thank you so much.